Hey, today we're going to be talking about the volume of rectangular prisms. So, first concept is what the heck is a rectangular prism? And we know that rectangular prisms are just a fancy name for really boxes. So, the first line we're going to fill in is boxes because that's what we want you to be thinking about when we talk about rectangular prisms. And the idea is that when you're thinking about these boxes in their volume, we're basically saying how many cubes, how many layers of cubes, or even dice if that's what you help to picture, but how many layers of cubes can fit into this box? And you'll see that if I'm trying to figure out how many how many cubes, like on the left here, can fit into this giant box over here, one way to do it is to start off by saying, well, let me kind of find just what would fit on that bottom layer. How many of these could I drop in to cover that bottom? Once I did that, I would basically be finding the area. So to find the volume of a rectangle, the first thing you do is you find the area of that base. Because once you've found that area, then what you can think about is how many stacks, layers of that area are stacked on top of one another. Because that's in essence saying what's the height. So if I take the height, Height, I'm going to try and spell it well here, but I'm a little nervous. My handwriting is going to be a little hard to read. Once I find the height, that's really saying how many layers I have stacked. So let's say I had, like this example, a 3 by 4, I have 12 fitting on the bottom. Well, each layer is another group of 12, so I can multiply that. That's a much faster way of doing it, which leads us to the part here that the overall formula we want, and again, I'm going to use my mouse just to sort of shift this up a little bit before we look at some more problems, is that, ooh, where did it go? I need the pen. Shoot, pen, where are you? Nope, 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 not that. Fireworks, hello, where'd you go? I'm having trouble now. Oh, there's the pen. The formula for the volume of prism is often written as the volume, which is usually represented as a V, is equal to the area of the base. So we just put A for area times the height. Now, because in the right rectangular prism, we know that that area, we can find that by writing the volume is equal to, well, the length times the width gives me the area, length times width, and then we multiply that amount by the height. So we're multiplying three numbers. And typically, as you're about to see in this problem below, we are going to have problems where, like here, I've got lots of numbers that I have to make sense of. But the ones that I'm paying attention to, so I write my formula, which is what you should always do. In this case, I'm going to write length times width times height. And I know my length is this 11. So my volume, I'm going to start substituting, is equal to an 11 times, well, what's this height? That's also an 11. That's this distance, this diameter. So I'm going to put an 11 here times, now when we think about, excuse me, that was the width. When we think about the height, we're saying, what's separating this front face from the back face? And it turns out that in this case, hidden up here is a 2 centimeter. That's the difference. So I have two layers of 11 by 11 stacked on top of themselves. So when I would multiply this out, I'd say the volume is equal to 121. That's the area of that square that's facing us. And I've got two layers of it. So my volume for this entire shape is 242. And now this is the first time we've used this measurement. We're going to say 242, in this case centimeters. Those are our units of measurement. But centimeters, take a look at this, to the third power. We multiplied three numbers. So our volume's 242 centimeters cubed, or to the third power. Now let's do the same thing on this next problem. Here we see it's not a right rectangular prism, but I want to make the connection to using the formula for volume equals the area of the base times the height, or the distance, how many layers we can stack up. And I think when I do this, this will hopefully make sense. Clearly, this is not a rectangle. This is a triangle. So what I'm going to do to find the volume is I'm going to start off by thinking about, well, that area has to be the area of a triangle. Base times height divided by 2. And then I'm going to multiply that by that height that is the distance separating the front triangle from the back triangle. So when I look at this triangle, I notice that I've got this line here, and then this red triangle here tells me that's a right angle. So I know that my 3 and my 4 are my base and my height. So I can rewrite this now. I can start beginning to substitute with 3 times 4 divided by 2. That would be the area of the triangle. And then I'm saying to myself, well, how many layers can I stack up between this front and the back? Well, it's that 1 centimeter here that tells me how wide this is. The 5 is just noise. It doesn't help me. Here's my entire formula for finding the volume of this, as it turns out, right triangular prism. So the volume here would be 12 divided by 2, or 6. 6 times 1 is still 6. 6 centimeters. And again, because we're going to volume, we're going to 3 dimensions, we're going to say that's cubed. Now, we're going to do a lot of these kind of problems. Usually the problems you're going to have will involve fractional lengths for these sorts of things. And we'll give you some practice to do that in just a moment. Enjoy.